Welcome back, everyone. Kevin Carpenter, CPP Events, here with Khalil Estell. Did I say that right?
You said that correct?
All
Hello.
right. Well, that's a good start for a Friday morning for me then. So I'm really happy to talk to you, Khalil, because so we met last year at ACCU. As far as I know, I mean, I'm sure you've done talks because you volunteer with Santa at the University in San Jose.
Mhm.
Um, your help with the state robotics, if
Mhm,
I
mhm.
remember right. And you can give
Yes.
the full names there.
Yes.
But it was like, yeah, so last year I saw you at ACCU and then you ended up keynoting for CPP Con and now you're back at ACCU keynoting.
Mhm.
How is that? How does that feel?
It's actually quite amazing. A couple of things. So I did a lot of public speaking back in college, but I never actually did any like technical ones. ACCU was my first ever real technical conference, and I was sweating bullets. Actually, I was sweating bullets at CPPCon as well. Probably gonna be sweating bullets this time too. But yeah, no. I after years of thinking about this stuff, I just really wanted to get it out there, and I'm so happy that the reception has been so positive. Just almost unilaterally, maybe there's like a few people, a few comments on YouTube going meh or weird, I don't care. But beyond that, like people like this stuff or interested in it, and I am more than happy to spread the knowledge because I think that there is a lot of what's the word I'm looking for? There's a lot of improvement and work and research in this space that
Yeah.
hasn't been done, and I really want to dig into it. And I also want to show it to everyone else as I dig into it.
So the thing that so I was rewatching your talk
Mm.
last year at ACCU, and yeah, you just knocked that out of the park. And the part that I think is
Thank you.
interesting is like, so for me growing up, I learned on a Z80 processor. It's like
Mhm.
I was talking with Matt Godbolt, and he's taking a Sinclair and making an emulator from it because we kind of came from that spot. At the same time, that Z80 processor, I worked with Heath robots. And so
Mhm.
I actually got to do the part where I'm turning pins on and off. And now with the ubiquity of having, I'm the name's escaping me, but it's like I have a little robot in the back that's got a pick
Mhm.
controller on it, and it's like using the I squared C interfaces to be able to talk to things, and so the detail you went into in last year's talk was phenomenal. And to your point, the other part that I think was interesting is the way that you took all of that, what I would say, like the part where you're like, yeah, you just can't use exceptions, but then the research level that you did in not just figuring it out, but then showing how you could reduce the binary size and the different pieces that you could tweak to do that was incredible. So
Thank you.
how are you going to top that this year?
Oh yeah. All right. So a couple things about this talk. So one of the things that I want to do about this particular keynote, because one of the things about this particular conference is that it's not just about C++.
Right.
I want to do a better job of. So the talk is very similar. Um, I've upgraded things. Specifically, I've gotten a lot of feedback from people, individuals who've spoken to me, things I've seen on Reddit, YouTube, and students who I've worked with who are doing research with me on things that they felt that I did not, I won't say a bad job in, but things that could be explained better. So there's
Hmm.
going to be better explanations. Not only that, but I am actually going to start bringing in a couple of small. I'm going to plan to talk about how these things aren't just for C++. They're not just for firmware. I do that to reel people in because people
Right.
think firmware and C++ exceptions good. No, that's impossible. That's not a thing. Uh, so I use it to reel them in, and I guess I'll add this one little bit here, which is one thing that I don't think a lot of people know is that like Rust uses exceptions. Their
Right.
panic is an exception of a single type. So if any of the work that I'm doing, because I think they use Clang's unwinder, so if I
Hmm.
can improve the unwinding for that, for GCC and Clang, then that would also improve other languages like Rust. The work that's done on this goes across languages. And actually, one last thing I want to add to this is I didn't put this into the slides. Maybe I should now. Haskell has exceptions, and they say
Oh
in the
wow.
little documentation, like there are situations in which every other option doesn't really work well, but exceptions works well. So they actually have a exception propagating thing inside Haskell. So I'm hoping to show that like exceptions have benefit beyond
Hmm.
just C++, beyond just firmware, in the way that I'm beyond my title,
Right.
but really throughout software development. And obviously we use it a lot. I just think that like a lot of people have given it a bad, it's been given a really bad name, a really bad look. It's looked at like it's the softer, easier thing. Like you're using it because I've literally heard people and seen text of people saying like, use exceptions because you're lazy and don't want to like, handle your errors properly. And I'm hoping to kind of fight back on that.
That's interesting because there's been, if I think of all the talks at CPPCon over the years, for example, the amount of talks about exceptions bad, or how to use exceptions and exceptions are good if you use them this way. And so there's definitely like two camps to that. And I can get that part. Like there's, I can think even in my own code that I've written before, there's parts where it's like, oh yeah, I'm just going to catch this because I don't really know what's going to come out of it. And on one hand, I get that lazy part because, okay, I really should have spent a little more time in my mental model to figure out what that could possibly cause. What is the states that could happen there? But then there's the points where, just like you gave in your first talk, it's like you're connected to an I2C bus, and you don't know. It's one thing if you have a closed system that you put these three devices on. It's
Yeah.
another thing when someone can simply add a device and your driver's supposed to pick it up.
Yeah.
And it's that kind of same thing. Like you make some sort of library interface, but if you really want to see how bad it is, throw it out into the public and see how it gets used, because everything gets used in ways you would never expect. And
Oh
that's
yeah.
the
Oh yeah.
that's the edge cases, right?
Definitely.
So
Definitely.
on exceptions, you've done the work to show the size, and all of that's
Yeah.
a positive experience you can get. But what is your overview on, like I was just saying, from using exceptions, that part of being lazy versus not? Give
Yeah.
me your take on that a bit.
Yeah, so this is kind of actually, I'm happy we can do this because this will go a little bit towards talking about the rest of the trilogy. So this is like part one of the trilogy of the exceptions comeback story.
Yep.
One first part I'll be talking about again at ACCU is the code size. I want to get that message out to people, but also the follow up talk, which I'm not sure when it'll happen. Still working on the slides for it, but it's on performance. It
Mm-hmm.
is improving the performance. I put this on LinkedIn recently, but my last numbers that I had from CPPCon was 88% faster than GCC. I'm currently at 93.4% faster than GCC. That last one, super proud of, because I had to do some like the first optimizations, like the first 15%. I'm gonna be real. This is technically a little bit of a spoiler for the next one, but it's small, so small. All I did was sprinkle inline all over the place and then recompiled and
Oh
saw how
wow.
fast it got. Yeah, no, it was easy. It was like that first part was easy. So I was like, oh snap, there's like things we could easily do right now to make this
Yep.
25-year-old code base faster. And then as time went on, it got harder and harder and harder.
Yep.
Um, but the other thing that I wanted to talk about on the third part of the trilogy, which is the exception insights tool, which we're currently working on right now.
Okay.
Basically, a tool, you give it your binary, and it should be able to tell you what exceptions, where your exceptions are emitted, where they're caught, and which ones you've missed.
Oh
And
wow.
missed would mean like either hits a no except function.
Right.
I want to ensure some way, but I don't know if C++ has the information. I want to ensure that if you get past the thread, that it also like tells you, hey, you missed it.
Right.
And also if it hits May, those are all the situations that we're looking for. Currently underway on that. We don't see any barriers at the moment. But one of the other things that comes along with it is this thing called, or this idea that I have called exceptional software design. So it's basically just designing your software around the idea that you're going to be using exceptions.
Right.
And here's one particular thing that I've had to do with my code to prepare it for the tool in the future. So people always ask me, okay, well, how do you handle function pointers with your analysis tool? Like if you have a function that returns nothing, it takes no arguments, how do you disambiguate it from all the other functions in your code? And the answer is you kind of can't. The idea is that you could have called anything could have been placed as that function pointer. It's basically the set of all possible functions that fit that signature.
Okay.
So you get a sum of all the exceptions that might come out of that. But it would be kind of disappointing if you have a function pointer and it says, oh, everything your program could ever throw is also coming out of this function as well. So a small thing that I started doing was I looked at some of my code and I thought to myself, since I have control over it and I can make intrusive changes, could I maybe consider that a callback for a scheduler, or I should say scheduler, for a timer that will execute a function at a certain amount of time in the future.
Mhm.
What if I just add a tag called schedule tag? Well, if I do that, now the API's signature has changed. Now, when I look through the exception analysis tool, it'll only show me the things that also have that tag. So it allows you to split things up. You can still have the underlying stuff still be void pointers and stuff like that, or sorry, not void pointers, function pointers that don't have any tags in them.
Mhm.
And you do a little, if you wrap them and then pass them along, this will help you. So this is things that we're thinking about. We're thinking about the tree structure of how all the exceptions propagate up and how you could write code to give you the most information about those exceptions as possible. So that's like where all this is leading up to, is a whole design discussion about how to design performant and safe code using exceptions, and where using result types and using errors as values is really key, which is usually at near the detection site. So yeah, there's a lot of stuff.
All right. So for everybody that has not already purchased their tickets, you need to get a ticket. So you're coming to ACCU. Flights are still available, I'm sure. Hotels still
Yes.
available. I'm looking forward to my 10.5 hour flight. And I think you probably have an hour more than me. But
Yeah.
we got to come see part one. Now, I happen to know of a couple other conferences whose call for papers will open soon. So you can get part two in there, I'm pretty sure.
I'll try
So
my
that
best.
next year, everybody can come back to ACCU again in 2026 for part three. So we've
Yes.
got the plan, we've got the release schedule. We should be good, yeah?
Yes. I'll try my best to hit that schedule.
Right on. Khalil, thank you so much for spending time with me today. I'm looking forward to seeing you in Bristol here in just a little over a week. And yeah, I'm excited for your talk, and congrats again on another keynote.
Thank you so much. And I'm excited to see you as well.
Have a great weekend.
You too. Bye.